I'm ready. One more time. If you don't remember it, make up another one.
Y is less than or equal to 8x minus 4.
Oh, we can't have two variables.
Oh.
Not yet.
Oh, okay. Right. So then just that, right?
Okay, so let's say 8 minus 2y plus 5. Good. That's fine. The variable is y. No problem there. Can anyone give us the first step?
Distribute?
Correct. So I have y less than or equal to 8, and then
Minus 2y minus 10.
very good. Like with linear equations, I want the same thing, at least at the beginning, right? I want to move the variable and have the variable on one side and everything else that doesn't have the variable on the opposite side. So obviously I will move 2y and then combine these two at the same time. So when I bring negative 2y to the other side, I know it becomes awesome. Thank you. Less than or equal to? Very good. Final step.
Divide both sides by 3.
That's it. So y less than or equal to negative 2/3. Now in interval notation, how will I present this? In interval notation. So let's graph it first. So this is negative infinity to infinity. This somewhere I have 0. I don't care for units. Negative 2/3.
Infinity to negative 2/3.
Correct. So that will be a full point, negative 2/3. So it will be negative infinity with a bracket. Exactly. Awesome. So the interval notation. Y is in the interval, negative infinity, negative 2/3. The interval is this. Infinity will always have parentheses. Any infinity plus or minus parentheses. If there is an equal symbol, then we will have to represent it by a bracket. Equal symbol, bracket. Very good. I'm going to choose an inequality from your text now. Okay, let's say something with fractions. 46 on page 203. And we have 4x minus 3 divided by 6 plus 2 greater than or equal to 2x minus 1 over 12. You could say this looks difficult.
That's 4x minus 2.
This one?
Yeah.
4x minus 3. Sorry. Sorry about that. 4x minus 3 plus 2 greater than or equal to 2x minus 1 equal over 12. So this may look difficult because of the presence of fractions, correct? Never be afraid of fractions. We can eliminate them in a blink. How? In this particular example.
Multiply both sides by the common denominator.
The least common, which is?
12.
Exactly. The least common denominator is 12. So let's multiply both sides, each and every term, everything by 12. Since I see fractions, I'm going to write for the fractions, instead of 12, I'm going to write 12 over 1. So I multiply everything by 12, but here I'm going to write 12 over 1. Here I'm going to multiply by 12. There is no need for 12 over 1. And then multiply here by 12 over 1. I will definitely simplify before I proceed. So when I simplify by 6, what do I get here?
8x minus 6.
So I get a 2. When I simplify by 12, I simplify by 12 and I get a 1. So now let's see what is left. 2 must be distributed to these two quantities.
Where I got the 8x minus 6.
8x minus 6 it is.
24.
Plus 24.
Is greater than or equal to 2x minus 1.
As you see, just from a simple multiplication of both sides of the inequality by 12, we got rid of all fractions. So there is nothing to worry about now. So now this becomes a linear inequality. It was linear anyway. Something like this, in which I combine like terms, move terms around, and solve for y. And that's the end of it. So I will combine like terms first. So 8x plus 18 greater or equal to 2x minus 1. I will bring 2x, I will bring 18 to the other side. When I bring 2x to the left, what do I get?
6x.
Do you all agree with 6x? Okay. Stop me if you fall behind. Stop me if you have questions, please. And then 18 goes to the other side, so this is negative 19. Final step.
Divide by 6.
That's it. So x greater or equal to negative 19 divided by 6. In interval notation, how do I write the answer in interval notation?
Bracket,
Correct?
negative 19/6, infinity, parenthesis.
Very good. Don't be intimidated by Tom and what his answers. If you have questions, stop me, please. Is this clear? Everyone, please say no. Have the courage to say no if it's not clear. I'll like to go back and explain. Is this okay? Is this clear how we got this? Everyone? Yes? Is it a yes? Okay. Now, let's talk about absolute value inequalities. That's a totally different story. There are two different types. And I will start by looking at the simplest possible for example from each. So here they are. One example would be the absolute value of x less than or equal to 2. And the other possibility, the absolute value of x greater than or equal to 2. So one more time, there are only two possibilities. When we talk about absolute value inequalities, there are only two cases. The first one in which the absolute value is less than a number, and the second one when the absolute value is greater than or equal to a number, positive number. Okay. What does this say to me? Here's what it says. It's asking me to find numbers. The absolute value is the distance between 0 and a number, correct? Okay. So it's asking me to find numbers x whose distance from 0 is 2 units or less.
2,
So
1, 0.
So let's take a look. I have here, what do you think?
0.
I am 0.
Yeah.
Negative 2. And I have here 2. So how many numbers have the distance from 0 exactly 2?
2.
2. Negative 2 and positive 2 are exactly 2 units away from 0, correct?
Yeah, 5 numbers.
But now I want to determine all real numbers, all x values, all possibilities of numbers that are 2 units away from 0 or less.
From negative 2 to positive 2.
Awesome. You understand all these numbers have a distance from 0, 2 units or less. Right? So anything between negative 2 and 2 will be the solution to this inequality. I'm going to do something that I would like you not to do. We cannot solve this. If I don't know how to change it into negative 2 less than or equal to x less than or equal to 2, I will not be able to solve. I'm not allowed to touch the absolute value. I cannot put anything in. I cannot take anything out. It's not a grouping symbol. So in order to solve this, I have to solve this. So the answer in interval notation is very clear. What is it? Can anyone other than Tom give us an idea? I should have said Tom and Alex. You're both grounded. Just kidding, just kidding. Okay, now the other one. Let's talk about the other one. What does this one say? This one says something else. Find all real numbers whose distance from 0 is 2 units or more or greater. Okay, one more time. I cannot include this, right? Because all these numbers have a distance from 0 less than 2. Where will those numbers be? To the left of
Negative 2.
or to the, exactly. Again, don't write this. I'm trying to make a point, something for you to remember. I can solve that. But now I will have to solve x greater than or equal to 2, exactly what you told me, or x less than or equal to -2. So as you see, the second inequality is obviously a little bit more difficult than the first one. Why? For two reasons. One is because the first one is a chain. Very nice, I solve everything at once. Secondly, this one is not a chain, right? So that one is a chain, this one is not a chain. So I have two different inequalities. This one over there, and this one over there. Second thing is, this keyword or reminds us of the fact that we have to have the union between the two solutions. There is no need here. This is an intersection. So can anyone dictate, other than Alex and Tom, the solution to the second one with the union in between? Anyone, give it a shot.
Is it just -2 union 2?
So first, you're right, I have to start with this. So remember what we said. So I have to start over there. Negative infinity, awesome.
-2.
Very good.
2. Well,
Good. Now I have to establish what?
the brackets,
Okay, yes, what is this?
parentheses,
Always. What is this?
brackets.
That's it. So x in the interval. Is that clear? In short, if you'd like to remember this in this way, it would be the first one is in between. The other one, outside. So in between, outside. Okay, let's look at an example. Let's say 94 on page 203. I have 2 minus x over 2 minus 1 less than or equal to 1. And you could say, wait a minute, this doesn't look like what you just talked about. True, it doesn't. It's more difficult. Indeed. What do you think would be the first step here?
Fractions.
Can't. I cannot touch the absolute value. Nothing. I cannot distribute. I cannot put anything inside. I cannot multiply. Nothing.
Add the 1 to both sides.
Of course. Of course. So the absolute value of 2 minus x over 2 less than or equal to 2. So maybe I should add to the keywords action keywords, cleaning it up. I have to clean it up. That's what we did. Or simplify. Same thing. I have to clean it up. Now, it still looks like it's different than the basic one. Not really. I'm asked to determine numbers. Yes, please, Alex.
What is that problem?
94 on page 203.
I mean, like, after the absolute value.
This little dot?
Yeah.
I'm sorry. Happy? I got it right here. Sorry about that. Okay, so it looks different, but not really. I'm asked to find numbers whose distance from 0 is less than or equal to 2. How do I change this? Remember, I can't touch it. How do I write? What do I write? This must be where? Where will I find these numbers?
From -2 to +2.
Exactly. I just have to copy. Exactly the same. Identical situation. It's just that it's a different expression. Now I have this in the middle, like I had x a few minutes ago. Good. How do I solve this?
Multiply everything by 2 to get rid of the fraction.
You could, but not yet.
Okay.
It's not wrong. You will get the same answer. But I recommend get rid of the weakest link. So let's get rid of the weakest link. Which one is the weakest link here? Exactly. I want to get rid of this first. How do I get rid of it? What do I do? Of course. Subtract 2 from all three sides. Subtract 2 from here, 2 from here, 2 from here. What do I get? What is the new inequality that I have to look at now?
-4
Yes?
is
Less than or equal to negative x over 2
Right.
less than or equal to 0.
Exactly. So -4 less than or equal to negative x over 2 less than or equal to 0. Awesome. Are you with me, everyone? Yes? Okay. Final step.
You said not yet when I suggested multiplication.
Now you can suggest it.
Okay. So then just multiply everything by 2. 0 times 2 is still
True. But I would like to do it in one step. It's not incorrect. It's perfect. I want to get just x. I don't want to get negative x. What will I multiply by?
-2.
Correct. So let's multiply everything, each and every side, three sides, by -2. What do I get on the left?
8.
Awesome. What do I get on the right?
0.
Awesome. Now let's think for a moment. Can I still say that 8 is less than or equal to x less than or equal to 0?
No.
No. Why?
Because you multiply by a negative.
I multiply both sides, or all three sides if you want,
You have
of an inequality by a negative number. I have to switch the inequality symbol. That's another thing that you should write in your little notebook. Yes. Do I need to refresh your memory on this procedure, or is it clear why we have to switch?
Q function.
Yes. So here's, and then I'll come back. This is not done. We have to write the interval notation in a second. So do you agree that 2 is less than or equal to 3?
Less
Except-
than, but not equal to.
Yes, but 2 is less than or equal to. Yes. So this is negative infinity, infinity. This is 2. This is 3. No units are required. I'm just explaining. So obviously 2 is to the left of 3. Any number to the left of another number must be smaller, correct? Okay, let's say for whatever reason that we want to multiply both sides of this inequality by -10. The left-hand side is -20, the right-hand side is -30. So this will be a -20 and this will be a -30. Can I still keep this?
No. Because if you were to keep it the same, it wouldn't be true.
True, correct. So I can't do that. So every time I multiply and divide both sides of an inequality by a negative number, I have to switch the inequality symbol in order to, as Tom says, he's right. If you want a false statement, you keep it. But we don't want a false statement. We want to change it, to reverse the inequality symbol. Is that clear? Awesome. Good. So coming back to our problem, because we haven't finished it, I have to read the inequality from the left, from the right-hand side to the left. 0 is very good, less than or equal to x, which is right. Always present the inequality in the correct order so you don't make a mistake when you write the interval notation. So now, can anyone give us the interval notation? X is in the interval.
Bracket 0, comma 8 bracket.
Awesome. This is how we deal with inequalities with absolute value, and I would like to look at another problem. I'm still on page 203. Yes, let's look at 86. Feel free to choose at any point in time if you have your book or you want to choose. I'm more than happy to do any problem you prefer. Of course, there is a little trick here. It's twisted, right? We are used to seeing the absolute value on the left and the number on the right. So, of course, they want to confuse us. But we are stronger than that, right? I have to read it from the right. Can anyone dictate what I should write?
So the value of 4x plus 7 is greater than or equal to 9.
Good. So again, this looks so much more difficult than the simple example that I started with. Not at all. I'm asked to find numbers whose distance from 0 is 9 or more. Where will I find those numbers?
Negative infinity to 9.
Negative infinity to 9 will include the interval negative 9 to 9, and that will not be correct. So let's summarize one more time. It's either this or that. It cannot be both. So it's either in between, like we had less than or equal to 2, or less than or equal to negative 9 union greater than or equal to 9.
I'm going to say it's from negative 9 to 9.
Okay, let's look at it one more time. I'm trying to find numbers whose distance from 0 is 9 or more.
Okay.
So this is not the chain. This is not the chain. This is the two totally. Yes, please.
Negative infinity and negative 9.
Careful. You would have been perfectly correct if this were just plain x, but it's not plain x. The reason why I cover it is because I want to mimic the simple example, so you know what I'm trying to do. But this is not x. So then what do I write? I write 4x plus 7 must be greater than or equal to, no, it will include negative 9 to 9. It's either less than or equal to negative 9 or greater than or equal to 9. It cannot include the middle part.
Negative 8.
Okay, it's very clear, it's not clear. Okay, so this is negative 9, this is 0, and this is 9. These numbers have to be here or have to be here, because this number has the distance more than 9, and this number has the distance more than 9. Give them just one more second. I know you have the answer. Is that clear? If I include this, look, the distance is less than 9. If I include this, the distance is less than 9 units. So I cannot include anything here. So then what are the options? 4x plus 7 to be greater than or equal to 9. Or 4x plus 7 to be awesome. Thank you. Is that clear? It cannot be between negative 9 and 9. 4x plus 7, whatever the number is, cannot be between negative 9 and 9. Because the distance would be less than 9 units. Good. So if you remember, this inequality always requires the union. So I have to solve this. I subtract 7. So 4x greater than or equal to 2. And then I divide by 4. Greater than or equal to 1/2. And this is done. Is this okay? One more time. I subtracted 7. And I divided both sides by 4. Is this okay, everyone?
No, wait a second. You subtracted 7, so then that should be effectively 7 plus 9, but you switch the sign. So.
But when I move one term from one side to the other, I have to subtract it in this case, right? So it becomes negative 7. 9 minus 7 is 2.
And you're subtracting 7 from negative 9, right?
No, this is positive 9. I haven't gotten to this one yet.
Right.
You're
So
way
first-
ahead. You're way ahead of me.
One, yes.
So for the second one, so then 4x less than or equal to negative 16. I'm subtracting 7. You're right. And then I divide both sides by?
4.
Yes.
You negative 4.
Good. And remember, the solution has to have the union. Can anyone give us a final solution with the union?
Let's see. Negative infinity to negative 4 union 1/2 to infinity.
Indeed. Any questions? Any questions? I'd like to go back to some different equations, other types of equations other than quadratic. Okay, so let's look at, so this is back to 1.6, other types of equations. So first I would like to look at a polynomial equation. Polynomial equations. If you have your book, you can choose from 1 through 10 on page 185. If not, I will. I will start with 8. 9y cubed plus 8 equals 4y plus 18y squared. Here's my first question. What is the degree of this polynomial?
3.
How many solutions do you expect to get? Exactly 3. If the degree is 4, 4 solutions. If the degree is 3, 3 solutions. Awesome. What would you do first to this equation? Yes. Set it equal to 0. Who said that? Alex?
No, not me.
Carly? Wow, wonderful. Exactly. I have to set it equal to 0. And how do I get them to the other side? In what order I should ask?
Subtract 4y and then
But in which order I really want them, so I can save some time and do 2 things at once.
right. Subtract 8.
So I have 9y cubed. Which will be the next in line? Yes, negative 18y squared. Which will be the next in line?
4y negative
Plus 8. And what is left on the other side?
0.
Absolutely 0. Awesome. Now, if you remember, I gave out a handout some time ago, and I just gave out to Ashley what I had here, so I don't want to waste your time. I may not be able to find it in a blink. It's the handout on factoring. And it has that little chart, if you want, like that little drawing that I created. Awesome. That one. So, oh, I did get mine. I'll find mine. It's right here. Of course, the last one. Okay. So, descending order. That's why I asked you, how do I present the polynomial? Descending order. Is there a greatest common factor? I don't know. Let's look. 9, negative 18, negative 4, 8. Is there a greatest common factor? No. A negative leading coefficient?
No.
I would have multiplied both sides by negative 1 if it were. Okay, so now finally I'm deciding which type of polynomial it is. Is it a binomial, a trinomial, or a polynomial? Which one? Exactly. This is my only chance. So here's how I do it. I look at the first 2 terms and I decide if there is a common factor, pull it out from these 2. Is there a common factor present in both first 2? 9. 9y squared. What is left in parentheses?
Y minus 2.
Awesome. Do not look at the other 2 and tell me what should you have from coming out from the other 2. Exactly. It is safe to write, of course, I accept any method, but is it safe to write y minus 2 first and then look? I need a sign and a factor.
Negative.
Yes?
9y minus 2.
Negative 4.
Exactly. Let's check.
4.
Negative 4 times y is negative 4y. Negative 4 times negative 2 is positive 8. Obviously, this is the common factor that has to be pulled out now from these 2 terms. This is a term, first term, and this is the second term. What do I pull out again? Perfect. What is left in parentheses?
9y squared minus 4.
And if you remember, I tortured you from day 1 with this. 1, 2, 3. They have to be in the back of our minds at all times. Which one? What do I do? What do I write? Hi, Rex.
3y minus 3y.
Awesome. Thank you very much. Difference of squares. And then we have 3 solutions. Can anyone give us those 3 solutions? From here.
2, 2.
Awesome. From here, remember you move -2 and you divide by 3.
Y equals 2 over 3.
Awesome. Here you move 2, but it becomes negative and you, that's it. How many solutions did we expect from the get-go?
3.
Because the degree was?
3.
Awesome. So these are polynomial equations. Let's discuss radical equations. Number 2. Radical equations. I'm on the same page. And I'm going to start with a simple one first, and then slightly more difficult. Let's say number 12. This is a review from the previous class, I hope. I solved these equations with my 012 class. I have not taught 036 and 037 yet. But 012 it has both classes together. Okay, so this is a radical equation. Can anyone tell us why is a radical equation?
Because the radical itself is square root.
Right, exactly. So how do I solve a radical equation? And by the way, what is the index here? I don't see an index. Is
If
it
you don't
5?
See 1 by default, it's 2.
Awesome. We do not write the 2. So by default is a 2. I want to eliminate the radical. That's the key here. How do I eliminate this radical? Yes, please.
Square side.
Exactly. Awesome. Why don't I cube? I want to cube both sides. Why can't I cube both sides? Because the index is 2. So only power 2 will clear the index 2. If the index were 5, what would I have done to both sides? Raise them to?
5.
Yes, exactly.
Is that equal x or is it?
Equals, I'm sorry. Thank you. Good. So what is the left-hand side then?
20 minus 8x.
What is the right-hand side?
X squared.
Good. Now let's look at this equation and think and decide what it is. What is it?
X squared plus 8x minus 20 equals 0.
Awesome. Why? Because the equation is awesome. Thank you, Brian.
Rational.
Linear.
No. Do we ever set a linear equation to 0? No. So it can't be linear. Can it be rational if it doesn't have x in the denominator?
No.
No. So what is it?
Quadratic.
Thank you very much. It is quadratic. And perfect, Brian. Thank you. Brian told us to set it equal to 0. It's typical for a quadratic equation. Awesome. Now I have 4 methods. Which one will I apply? I suggest complete the square. No, absolutely not. So which method would you use? Yes, unless I can factor like that. Can I factor like that? If you say no, I can, then I will use the quadratic one.
Yes, okay.
Yes, I can. Okay, so what is it?
Negative 10 and 2.
So which one is negative?
Oh,
Yes. Yes, because the sum has to be 8x. 8, correct. Good. So the sum has to be 8, sorry. So then the options are? And I will say not so fast. What does that mean?
You have to plug it into the sheet of math.
Right, why?
Because sometimes it cannot work.
Let me explain what happens here. if I move 5 from one side of the equation to the other, will that change the outcome, the final solution?
No.
No. If I divide both sides of an equation by 2, will that change the final solution? If I multiply both sides by 10, will that change the final solution?
No.
If I decide to add 5x to both sides of an equation, will that change the final outcome?
I would say so.
Absolutely not. It's like adding, on a balance, adding 5 pounds here and 5 pounds here. The balance is still intact. This principle is not, all what I just said are basic principles, meaning the equation that I apply these procedures to will have the same solution with the original one. This procedure of raising both sides to a power, it's not a basic principle. So it is allowed, but it's not safe. This is my only chance to eliminate the square root, but it's not a safe procedure. That's why Alex is right. Nobody knows if these are the correct solutions till we go back and check them in the original problem. Not this. That's not the original problem. The original problem is this. In this equation, I go back with 2 and see if it's correct. I go back after that with -10 and see if they both are the same number. If not, I'll have to exclude those. If a solution does not work in the original problem, it's called extraneous solution. A solution that does not work in the original has to be discarded. It's not good. So I'm plugging 2. So -8 times 2 is -16. How much is 20 minus 16? How much is the square root of 4?
2.
Obviously, this works. Right? It works. Now I'm checking -10. Can -10 work?
No.
No.
Why?
Because the square root can't equal negative.
Awesome. The square root can never be negative. So I already know the answer is -10 is not a solution, but let's go ahead. -8 times -10 is positive 80. 80 plus 20 is 100. The square root of 100 is 10, but this side is -10. Is this the same?
No.
Absolutely not. So this is called, hello, extraneous solution. It's a byproduct of a procedure that is not safe. Could both work? Yes, it's possible. Could none of them work? Yes, it's possible as well. In this case, we only had one solution. Any questions? Any questions for me? Okay, let's take a look at solving equations with rational exponents. Number 3, equations with rational exponents. Equations with rational exponents. Okay, I'm still on page 185. Let's start with 34. And the equation is x plus 5, everything raised to 3/2 equals 8. What type of equation is this?
Rational. Quadratic? No. Linear? Like,
It's an equation with rational exponents.
Thank you. Sorry, I trapped you. It is right there, right? It's not linear, it's not quadratic, it's not radical.
it has a rational exponent, so it's
Yes,
its own
actually it is radical. It is radical. Because,
Oh, right, yeah, because of the fraction.
yes, it's the square root of, yeah. So, but let's say it's a different category of equation with rational exponents. Perfect. I want to eliminate this first, and then I will eliminate 3. But I want to eliminate 2 first. What should I do to both sides? And let me just remind you here that this expression can be written as this. A square root is power 1/2. So that's exactly what we eliminated. We eliminated power 1/2. So in order to eliminate power 1/2, what should I do to both sides?
Root. Square root.
Square. Square. This is the square root already. It's 1/2.
Square root of it raised to the third power.
No, not yet. So I'm going to square both sides. Good. So what is the left-hand side?
X squared plus 35.
Yes, because I multiply 3/2 by 2/1, right? 3/2 times 2/1, I simplify and I get 3. Agreed? The right-hand side is 64. What will be my next step? Awesome. That's my only chance. Remember, I squared both sides and I have to check. But when I take a cube root from both sides, I don't have to. But since I squared, I still have to go back to the original problem. Yes, indeed, I have to take the cube root from both sides. The left-hand side would be?
X plus 1.
Right. The right-hand side will be?
4.
And finally, the solution is? Awesome. It comes with a question mark. Because I employed a principle that is not safe. Which principle? Not taking the cube root from both sides. That's okay. That's safe.
Squaring both sides.
Squaring both sides. So I plug in -1 here. -1 plus 5 is 4. So we have several ways, but I want to show with a graphing calculator since I have it right here and I didn't forget to bring it up. So I have 5 caret in parentheses, which power again? 3/2. What should the answer be if -1 is the correct solution? Thank you, of course. If the answer is not 8, then -1 is incorrect, correct? Agreed? Something is wrong. We did something. I did something. So let's look at it again. Oh, of course, it was 4. I put 5. Sorry. It was 4, right? -1 plus 5 is 4, and I wrote 5. Sorry about that. My mistake. So 3 divided by 2. So one more time, what should the answer be? If it's not, then I messed up something.
Oh, you didn't.
This time I didn't. It happened. This time. Good. Any questions? Yes, please.
Would it be improper to write like the square root of x cubed plus 5 cubed equals 8?
No, it will not be. It's the same thing.
So it'd be the same thing.
Yes.
Okay.
So you could write x plus 5 to the third equals 8.
That's the same thing as.
Absolutely. Yes. Yes, please, Dimitri.
What makes squaring it unsafe?
Very good. Awesome question. Here's the answer. I don't want you, this is awesome. I don't want you to believe anything. This is a lesson learned. Don't believe anything. If something is not 100%, you should always ask. Okay. So let's say I have the equation x equals 2. And let's say for whatever reason, I decide to square both sides. This is what we did, right, in the previous equation. Will I ever square this equation? No. I'm just illustrating, trying to convince you why and what happens. But we will never square x equals 2. But I just want to show you what happens when we square. Okay, so let's square this. What do I get on the left-hand side? What do I get on the right-hand side? Now, forget about where I started. And I would like you to tell me how to solve this equation.
Square root.
Right. We know we have 4 methods. This is quadratic, and we know how to take the square root from both sides. Awesome. So let's take the square root from both sides, and please tell me what I should write. It's quadratic, right? Now let's go back. I got 2 solutions. Which of these 2 makes no sense? And it will be called extraneous. And it's a byproduct of an unsafe procedure.
-2.
So I got two solutions, but I'll say, no way, this is where I started.
One that works.
I cannot put -2 in here. So I will say only x equals 2. X equals -2 extraneous solution. Clear? Awesome. Very good.